All right, so in the 211 lesson, we were looking at tile patterns, their tables, and their equations, and we were looking at both the initial value and the growth. And today we're going to throw in graphs as well. So things to think about: why is the line steep versus being less steep? How is growth related to the steepness? And where do we see that starting value, that initial value on the graph itself? So we have a table for a figure that we can't see. So figure number 0 has 2 tiles. Now I did already label my axes, not only with words, but also with numbers. So 0, 2, 1, 7, 2, 12, 3, 17, and then the last one would go off the table, but that's okay. Now, this would be a discrete pattern. You would not typically connect the dots because there is no figure 1.5. However, when we talk about graphing and then writing it as an equation, the equation represents a line. And so we will often think of this as a connected line when we're trying to make the jump from graph to equation. Make a graph that represents this tile pattern should the points be connected, and we would say no. Draw a continuous line through the tile pattern points and extend the line to the edges of the graph and beyond. So we would start here. We don't have any negative figure numbers. We would draw a line through with an arrow because it could continue to go on and on forever. The line you drew models the growth of the tile pattern, and models are often imperfect, but they're useful in describing complex situations and for making predictions. What assumptions does this linear model make? It assumes that you could do pieces of tiles or partial figure numbers. When we connect the dots, it sort of pretends that we have pieces of tiles, that they are possible, and that partial figure numbers are possible. Does the model in the previous problem appear to be a function? Like, does it pass the vertical line test? Sure. If so, write the equation in function notation. So remembering that function notation was the one that started with f of x instead of starting with y. Let me slide this up just a little bit here. And function notation starting with f of x instead of y equals, and I've got to think about my growth. So I'm going plus 5, plus 5, plus 5. So this would be 5x. And then my initial value here is a 2, so plus 2. And why is it a function? We could say passes the vertical line test. We can also say only one output for each input, which is more the definition. The 3 graphs following each model a different tile pattern. For each model, A, describe how the tile pattern grows and the starting value. So how many tiles are in figure 0? So if we are looking at figure 0, on here is 0, we would go up until we hit 3. We can look for the coordinate that starts with 0. So figure 0 has 3 tiles. And the growth pattern. So what is happening? Every time I go over to one new figure, 2 more tiles. One new figure, 2 more tiles. So my growth pattern would be plus 2. So what are we doing? We're adding 2 new tiles to each new figure. Write an equation that relates the figure number x to the number of tiles y. So if it's a plus 2, plus 2, plus 2, it's repeated addition. That's going to be y equals 2x. And then our initial is 3, so plus 3. Decide if the graph represents a function. Well, I don't see why not. It's linear and it's not vertical. So we would say yes. If so, write the equation using function notation. So that would be f of x equals 2x plus 3. And if not, explain why not. Oh, this one does. It passes the vertical line test. You could also go back to that same definition before, only one output for each input. All right, so page 2, I'm just switching pages. You'll notice that I actually have a stack of papers here, so hopefully it sounds less annoying when I'm writing. Describe how the tile pattern grows and the starting value, number of tiles in figure 0. How does X represent the figure number and Y represents the number of tiles in the figure? So this one doesn't have the grid on it. It just has the necessary information. So because it is over one figure up 12 tiles, we would say 12 new tiles for each new figure. Figure 0, if I look over here, it tells us that the intercept is 9. So figure 0 has 9. Repeated addition is plus 12, plus 12, plus 12. So the equation is going to be y equals growth 12, x plus initial value 9. Describe if it represents a function. Sure, passes the vertical line test, linear. It's not vertical itself. So we would do function notation, f of x equals 12x plus 9. That tells the reader it is a function and it passes the vertical line test. All right. Now this one, you'll notice they've done something a little different. They didn't give us coordinates. They did give us the values just on the x and y axis. They gave us some points back here in quadrant 2 with the line sort of extending down into quadrant 3. Which is fine. It doesn't really change anything for us. We're looking for the same pieces of information. How does it grow? Well, this is 1, 2, 3, and this is 1, 2, 3, 4. I'm just double checking that they didn't change the scale on us. So if I go from point to point, it's over one figure, up one tile, over one figure, up one tile, over one figure, up one tile. So the growth pattern for this is just plus 1. So it grows by adding one tile. And the equation then, growing by one tile, and then figure 0 on the y-axis is 0, 3. Add that in there, is a 3. So y equals 1x. We don't write the 1 plus 3. There is an imaginary 1 there that we don't need to write. Decide if the graph represents a function. Guys, same thing, right? It's linear. It's not a vertical line, so it passes the vertical line test. Function notation starts with f of x. All right, 214, the graph at the right. So this is another idea, another way to show your same sort of like growth pattern. And it says the line at the right shows a linear model for a tile pattern. How is the line growing? That is, how many tiles are added each time a figure number is increased by 1? Now this increase is by 3. So if I go up 3 figures, I go up 27 tiles. So I would need to do 27 divided by 3 to get that each figure goes up by 9. So we divided the change in y by the change in x. And that's the first time that we've used that triangle. And that triangle is delta. So we divided delta y by delta x. And it just stands for the change in y. We went up 27 tiles. By the change in x, we went over 3 figures. So this is our delta x, and this is our delta y. The triangles drawn on the graphs in 213 are called slope triangles. A slope triangle is where you show your change in y over your change in x. Slope is a measure of the steepness of a line. It is the ratio of the vertical distance to the horizontal distance. Vertical distance is read change in y, or delta y, while the horizontal distance of the triangle is called delta x, or change in x. Note that that little triangle is the Greek letter delta and is often used to represent difference or a change. So the vertical distance here, your change in y is 2 tiles, and your delta x, your horizontal change in x is 4. So delta y is 2, delta x is 4. We would do 2 over 4, which is either 1/2 or 0.5. And that's your slope. Your rise over your run. Oh, that should sound really familiar. Rise, change in y, over run, change in x. A lot of times you would see us do it here so that rise was first and then run was second, and it's the same concept. Here we would call this rise, and here we would call this run. Draw several smaller slope triangles for this line and check to see, does this work? Like, so if I go over 1, I only go up 1/2. Up here, if I go over 1, I only go up 1/2. So it does continue to work. Whether we do a large slope triangle or a small slope triangle, they have the same value. Using the smaller slope triangles, you would have 0.5 over 1, which is just 0.5. So slope of 0.5, which is also our growth. So it's going to be y equals 0.5x plus, and the intercept at 0, 2. So our initial value is 2. Or you could use the fraction for 1/2. And they're both fine. This question really isn't in context. So there isn't a definitive the fraction is better or the decimal is better. If this were a word problem and there were some context to the question, or we had been dealing with money, we would go with decimal. If we were measuring things in inches, then we would go with fractions. And this doesn't have that, so you could pick either one. All right, so the last page that we have, use the line graphed at right with slope triangles A, B, and C. So 3 different slope triangles on there. Slope triangle A is the largest one closest to the origin, and that one has a change in y of 6 over a change in x 4. So that one is 6 over 4, or 1.5. And triangle B is a height of 3 over 2, also the same as 1.5. So what do you notice? They have equal values, which makes sense because they're on the same line, and continuous lines would continue to have the same slope no matter where you picked those numbers from. So what is the vertical distance, delta y, for slope triangle C? So it's got to be something over 3 that would still give us a value of 1.5. So it would be delta y over 3 still has to give us a result of 1.5. Now, I can do the inverse of this, right? I can multiply both sides by 3 and get 1.5 times 3, and it would have to be 4.5. Delta y would have to be 4.5 to be divided by 3 and get 1.5 as the result. So delta y must be 1.5 times 3, because 3 was the delta x. It was the change in x. Draw a slope triangle on the line with a horizontal length, delta x, of 1 unit. What is the vertical length? So if I only go over 1, I go up 1.5. And that's the whole point, that if I go over one figure, I go up 1.5 tiles. Draw a slope triangle with 1. What is the vertical length of this new triangle? 1.5. What do you notice? The height, and this is really important. If you highlight nothing else in this section, this is really important. The height, when delta x equals 1, anytime you're just changing by one figure, is always going to be equal to the slope. So anytime you can get delta x down to just a 1, delta y is the same as the slope. What happens to the slope when the slope triangles are different sizes? The slope remains constant because the line is straight. And that's kind of the definition of a line. It has to keep the same slope because the line is straight. And the last question on there, 217, Michaela was trying to determine the slope of the line shown at the right. So she selected 2 points where the grid lines intersect and then drew a slope triangle. So what we're really saying is Cynthia chose 2 good points. She didn't choose like a random point here that she can't really tell what number it is. She chose a point that actually is directly above 4, directly across from 6. It makes a good coordinate. She did the same thing over here, directly above the 8 and directly across from 3. So good coordinates are coordinates that are right on the crosshairs, that have nice integers for both the x coordinate and the y coordinate. Essie thinks that delta y should be -3. Cynthia is saying delta y should be +3. Both of them saying that there is a change in 3. Essie is saying, well, because it's pointed downward as we move from left to right, it should be a -3. And that means that Essie is correct. Essie is right. So the growth, and I'll put growth in quotes for this one because it's actually a decrease, right? The growth y is decreasing as x is increasing. And we've talked about this before. We've also used the phrase negative correlation, but that means that we have a negative slope. Or we could say a negative growth, and you'd kind of put growth in quote. Quote, when writing the slope of the line, Michaela noticed that Cynthia wrote -3/4. Essie wrote negative in front of the 3/4. She asked, are these ratios equal? And we would say yes. The change in X is 4. The change in Y is -3. So you can either write -3/4 or you can put the negative up with the 3. It can be sort of out in front or it can be assigned to the numerator. Those are the most common. You rarely see a negative assigned to the denominator, though it would mean the same thing. So our change is -3/4. X plus, and then we just need to check here our y-intercept. Our initial value is 0, 9, where it crosses the y-axis. The y-intercept plus 9. Hope to hear from you guys with any questions, comments, or concerns so that we can discuss those soon. Have a great day.